So the lesson before this for 3.1, we talked about slope-intercept form, which was when you had y equals mx plus b. And so now we're going to look at a different form, and it's not called slope-intercept form, it has a different name. So for 3.2, we're actually be looking at something called standard form. So how do you write it and how we're going to use it? So the standard form of a linear equation in order to find the correct coordinates. And we're also going to graph some of these. But first, a new word. Linear combination. So what is a linear combination? It kind of goes hand in hand with this new standard form. So it's an expression in which all variables are raised to the first power. So we don't want to have any exponents here. And they are not multiplied or being divided by each other. That's specifically talking about the variables. We don't want like x over y or x times z or whatever. We want everything to be separated by addition, subtraction, no powers at all, and you don't want to have variables being multiplied or divided by each other. You can do it with numbers, but just not with variables. So for example 1, are the following linear combinations? And then we'll say why. So first one, 3x plus 2y. Is that a linear combination? Yes. Why is it? Well, the variables are separate by addition, and we're only being multiplied by some numbers. And there's no powers. Looks perfect. B, is that a linear combination? 3xy plus z. Hopefully you'd say, no, it's not. Why? We have variables being multiplied together. So the variables are multiplied together. How about G plus H? No numbers, but we also don't have multiplication or division with variables, so we should be okay there to say yes. It's good. And the last one, 3b minus 8h to the fourth. So you're allowed to have subtraction. That's okay. You can have numbers again. This should be a no, however, because what's wrong with it? There it is. H is to the fourth power. So I'll say has an exponent. So we should be able to identify, and we're also going to be creating linear combinations like A and C. So the first thing we're going to do is actually create one in this situation, for example, 2. At the local football concession stand, hamburgers cost $2.50, underline that, and hot dogs cost $2. Suppose you have $30 to spend for hamburgers and hot dogs for a family gathering. So step 1, we're going to go through the steps and also graph it as well. First thing they want us to do is to write an equation relating the number B of hamburgers and the number H of hot dogs you can purchase to spend all the money. So they want us to use B for burgers and H for the hot dogs. So how are we going to do this? We're going to make a linear combination. But we're also going to have it equal our $30. So we're going to first off make the linear combination. So it costs $2.50 for the hamburger. So we'll do $2.50 times the number of burgers we get. So $2.50B. And then we're also going to be buying the hot dogs for $2. So we're going to add 2 times the number of hot dogs you buy. So this would be the linear combination. And then we're going to add to it. They want us to write an equation. So to add to that, to make an equation, we'll put equals 30. That's the total amount of money we have to spend. So depending on the number of burgers and hot dogs we buy, we could plug that in and have it equal to $30 to spend all the money. That's kind of the goal here, is we want to spend all the money that we have. So what kind of combinations can we get to spend all that money? All right, step 2, solve the equation in step 1 for H. So now we're going to get H by itself. So how do we do that? First thing we're going to do is we're going to move this quantity over here, 250B, by subtracting it on both sides. So this will cancel out. We'll get 2H equals, I'm going to put the B with the variable part first and then put 30 beside it. So it's going to be negative 250. They're not like terms, so you can't put them together, plus 30. So they stay separate. And the last thing we have to do is to get rid of the 2. Since you have multiplication, we need to divide. So let's see if I can squeeze this in here. Divide by 2. And then we have to divide the entire side by 2 as well. 2's cancel out. So we have H equals. So what happens when we divide 250 divided by 2? That's going to be, well, what's half of 250? That's going to be a negative 1.25 B. Don't forget the 2 has to go to both things. So 30 divided by 2 is a positive 15. So that's step 2. We solved this for H. And the whole point of doing this really is that so we can get to step 3. We want to graph this equation. If you look at the original one that's in blue up here, it's not really obvious how to graph this. What we do know how to graph is the good old y equals mx plus b, right? We know that this is your starting point, this is your slope. So if we have it written in this form, even though we're using h and b, it should still work out to graph it. So how are we going to graph this? Well, h would be like your y value, right? So we're going to label the y-axis as hot dogs. There we go. And then the x-axis will be labeled as burgers. And we want to have a starting value of 15. And so I believe there are 15 blocks here. So we can just probably count by ones. Then we're going to count by ones on both axes. So I'm just going to label it every 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Do the same thing on the x-axis. 1, 2, 3, 4. All right. So how do we graph this to complete step 3? We're going to start at 15. That's your y-intercept. Let's change back to blue. So I'm going to start at 15. Put a dot there. And this is our slope. So we kind of have to figure out, well, how are we going to graph this? 1.25 is the same thing as what? Think about like how many quarters you would have. This would be the same thing. So I want to put it as a fraction so I can count blocks. I'm going to rewrite this as, instead of saying 1.25, this would be the same thing as 5 over 4. Negative 5 over 4. The graphing calculator can actually do this for you. You can type this in there and change it to a fraction. So I'll have to show you how to do that at some point. So you don't have to actually know how to do it yourself necessarily. So this will be the fraction that we use. We're going to go down 5 blocks and to the right 4. So count down 5 and over 4. 1, 2, 3, 4. And that will be a dot. Then we go down 5. 1, 2, 3, 4, 5. Over 4. 1, 2, 3, 4. And then down 5 again. 2, 3, 4. Right there. All right. So we have all the points. And one thing we're not going to do for this graph is we're not going to connect the dots. And you'll see why in a moment. But right now we just want the dots. So in step 4, we're going to identify all the points in the graph that correspond to a possible combination of burgers and hot dogs you can buy. So we're not going to connect the dots because we only want to talk about the possible combinations that spends all $30. And the only possible combinations you can have with the prices of the hot dogs and the burgers are these 1, 2, 3, 4 points. So what are the possible combinations? One is you could have 0 burgers and all 15 hot dogs. So as a point, right, we're basically doing, as a point, we're going to do burgers, comma, hot dogs. Let me erase this here. So we could do 0 and 15 hot dogs, right? We could do, what else? 1, 2, 3. Looks like we do 4 burgers and 10 hot dogs. We could do 6, 7, 8 burgers and 5 hot dogs. And the last combination would be only burgers. We could do 12 and then 0 hot dogs. So these are actually the only combinations you could possibly have of hamburgers and hot dogs to spend all $30. The only ones you could have. And it's all based on this graph. So we're going to talk about like kind of when you should connect dots and when you're not supposed to connect dots. So in this real world situation, you would not connect the dots, because if I were to connect the dots, so just pretend I started doing this, right? You're trying to say that any of these points here would work as a combination of hamburgers and hot dogs. But that's not true. There's only a very specific number of hamburgers and hot dogs that would work, because you can't buy a partial amount of a burger or a hot dog. And then connecting these dots would mean that you're allowed to have any number on this line that you wanted. You can't pick a certain amount. So that is actually called a discrete graph. So there's 2 different types. Continuous is what you're really used to when you connect the dots. So that's whenever you have the domain and range contain all real numbers. So that's whenever you actually draw a line. Discrete is what we just did, a situation where it doesn't make sense to contain every single number, because we're buying things that come in specific quantities. You can only buy 1, 2, 3, 4, or 5, and so on of burgers and hot dogs. So as an example, we could say buying burgers and hot dogs. So what would be an example of one where you would want to connect it, where it would make sense for every number to be a combination? I'll give you one. How about whenever you go and pay for gas? So you're pumping gas. Anything where it makes sense that you could buy a partial amount. So can you buy a partial amount of a gallon when you pump gas? Sure. And can you also spend a partial amount of money? You don't have to spend, $1 or $2 or $3. You could spend $1.47. So that would be an example where pretty much any combination will work. As soon as you stop pumping the gas, your charge stops, and you can see how much you put in and how much you're charged. And usually it goes out to a couple decimal places. So that's called continuous. The one that we did is called discrete. It doesn't make sense to connect the dots. All right, example 3. Give one different situation that could be modeled by the linear combination equation 6x plus 3y equals 30. So it kind of looks like the one we just did. Still equals 30, but now we have 6 and 3. For your situation, we're going to state whether the function is discrete or continuous and explain what the point 3, 4 represents. So we're just going to make up a story. I'm going to identify what all this stuff means, as well as the 3, 4. And the easiest way to usually come up with these is just to make up something that you're buying and see if it makes sense. So I'm going to try to do one that would be continuous. Yeah, sure. Let's do that. I'm going to say X is going to be pounds of cheese. Like you go to the deli and they have to slice the cheese and you get a certain amount of pounds of cheese. And we'll specifically say that it costs $6 per pound. My Y value, what else am I going to be buying? Well, what else can we buy at the deli besides cheese? How about some meat? I'll do pounds of, how about ham? Maybe buy some sliced ham or just cut up ham. And how much would that be? So I'm just looking at this. We did 6x, which is 6 pounds of cheese, or $6 for a pound of cheese. And then 3y will be 3 pounds, or $3 per pound for ham. And just like before, right, we have all these things labeled as money. $6 here, $3 here. 30 is going to be total amount to spend. So we have $30 to spend. So that takes care of the entire equation. And what would we have left is the 3, 4. This would be your xy. So what does that mean when you plug in the number 3 and 4? When x stands for pounds of cheese and y stands for pounds of ham, we would say that we actually went out and we bought 3 pounds of what? Well, whatever x stands for. We bought 3 pounds of cheese and 4 pounds of ham. The last thing we have to discuss is whether this is a discrete or continuous one. I tried to come up with one that would be continuous. Can you think about why? You don't have to buy a whole pound, right? When they weigh it, it can come up to whatever decimal point. So you can have a partial amount of a pound to combine and get $30. You don't have to buy 1 pound at a time. So this is actually a continuous example. So it's continuous. And the last thing we just need to cover to put in here for the notes is standard form, which is kind of what we've been doing, but standard form is basically a linear combination, ax plus by. That's the linear combination part, and then just is equal to c. That was standard form, and then we also had slope-intercept form, if you remember from the lesson before. Slope-intercept is that y equals mx plus b. So what we did today is we took standard form and we rewrote it into slope-intercept form so that we could then graph. And that's when we put some dots on there. So that is the end of the lesson. You can finish up the huddle and the mastery, and hopefully it's not too difficult. I don't think I have to go over anything for the huddle and mastery. It should be hopefully easy enough to do on your own. And that ends 3.2.